off the talk. Welcome, Nick.
Awesome. Can you guys hear me and see me?
Loud and clear. You're ready to
Great.
share.
All right, then I'll share my screen. Okay, and this goes to full screen. Is this full screen, or am I in semi-full screen?
It's not a full screen yet, but
Okay,
if you do that, I'll just give you audio
let's see if I
feedback.
can get this to full screen. Okay,
So what
it's
you want
not.
to do is present instead of full screen
Okay.
on the top right.
Okay, let's see here.
The button on the top right.
Present. There we go.
Oh, there we
Great.
go. Yes.
Awesome. All right, so my name is Nick, and I am presenting for the Fuel team, and we're doing optimistic roll-up scaling, and I'll get into it because it seems like we've got a half hour, so let's do it. Today we're just going to be going through our Fuel optimistic roll-up, sort of what it brings to the table, what UTXO models can do in terms of scaling and throughput, and sort of our take and approach on where scaling is headed and where we think we can add value to the ecosystem in the space. So just to dive right in. So Fuel is a permissionless, trustless layer 2 protocol for Ethereum for low cost, high throughput value transfer and exchange. Our main technique that we use is highly optimized optimistic rollup design. And our focus, which takes top priority over everything, is parallelism. So our designs feature sort of an approach where instead of designing for specifically the language down, we're designing for where we can get throughput up. We think we can offer a lot of interesting benefits with minimal trade-offs using this technique. And so far we've been doing pretty well. So before we get into too many details, we have one announcement we'd like to make from the Fuel team, which is that currently with some of our most recent tests, and thanks to the Hubble project and Barry Whitehat, we were able to get 4,300 CPS for transfers and swaps. So we think this is a significant increase, and it's definitely putting us at a high throughput advantage over a lot of different designs. And the main thing to bring home here is that it scales on consumer hardware. So we even think we might be able to validate blocks even on mobile phones, validating these large 4,300 TPS blocks. This is obviously more fun than it is realistic, but it's something to be said, and just given the way that our validation computation works. So to get into what Fuel can do, because I think there's going to be more presentations on optimistic rollups and more presentations on layer 2 and the trade-offs. So we just thought we'd focus on what Fuel brings to the table and what it can do. So our current design features native colored coins. So we treat ETH, ERC20s, and NFTs as sort of first-class citizens within the layer 2 itself. And this also falls into an approach that we think layer 1 is still base settlement layer for all of these assets and base settlement for protocol design. But we think layer 2 is a good option to scale these assets. And so our focus is to bring, a lot of throughput and scale to these assets and provide a service that can get you the most efficient scale. The second thing that we'd like to focus on is multi-user transactions or partially signed transactions. So with Fuel, we allow for a trustless exchange between two or many parties within a single transaction. And you can think of this as offering a way to do non-custodial order book exchange, or even other models that don't even feature an order book. So it allows for a lot of off-chain settlement and a lot of off-chain exchange that you wouldn't normally get if your transactions don't allow for multi-users and multi-tokens. So this is one really interesting aspect of using multi-token UTXO model. So the next thing that we'd like to go over is a focus on the op return. So like some protocols like Bitcoin, we have an open op return for data. And this allows for sort of arbitrary data blobs, and not only arbitrary in the sense that you can put any data there, but also arbitrary in the sense that they can be accessed or validated through our optimistic rollup contract and deployment on Ethereum, which also means you can build other logic and realities around data posted on Fuel. So one application you could imagine being used for arbitrary data is something like decentralized Twitter, where you're getting a sort of signed payload, around data, and then that's going on to a eventually into an Ethereum block somewhere. And what Fuel's doing is sort of organizing, publishing, and making the process smooth and efficient to produce this data. So you could imagine a decentralized Twitter, you could imagine decentralized social networking, or just anywhere you're officiating data using Ethereum and using our particular technique. So this is one really cool sort of aspect of what we can get done with Fuel right now. The second thing, which we think is incredibly important, both to the layer 2 ecosystem and to Ethereum more broadly, is hash time lock contracts. So Ethereum has actually been able to do these since since mainnet was launched, and hash time lock contracts are a very simple mechanism to allow for cross-chain atomic swaps, to allow for immediate withdrawals out of different DeFi protocols or different layer 2s. And they allow for migrations as well. So they're a great tool for migrating from one version to another, say your own rollup. So to talk about this a little more, the hash time lock design is quite simple. It just allows for parties on both sides of a blockchain reality. So say one party on layer 1 and one party on layer 2, to be able to exchange in a way that allows the party on, say, layer 2 to easily exit to layer 1. And you're doing that with just a hash and release function. So it's very simple contracts. It can be made relatively efficient and allows for bridging of these different protocols. You could also imagine bridging different layer 1s. So going between, say Ethereum and going between Avalanche, or going between Ethereum and going between XDAI. Hash time locks provide a really great way to do this. And you can also imagine going between different optimistic rollups. So going between, say, Fuel and Optimism, or Optimism and Arbitrum, or Arbitrum and Fuel. So hash time lock contracts give us a lot of utility, and they allow us to sort of jump chains where liquidity is available. So we support those natively, and we support them across every token that we have. So the next thing that Fuel has a pretty big focus on is mass token airdrops. So Fuel supports pre-signed transaction chains, and this allows us to actually form an interesting pattern using our 8 input in, 8 output transaction formats. So essentially you can start with a single input in, say a deposit or a large amount of liquidity from a single input or deposit. And then effectively we can use that single deposit in a transaction chain and sort of Merkleize that, or it's like a Merkle tree, and pre-sign trees for dispersal, such that users in the hundreds of thousands could be dispersed a transaction, and you would only need to pay for the transactions that are getting picked up. So this allows for a unique pattern of dispersal and pickup for mass token airdrops. So we saw something similar with the Uniswap airdrop, which was really awesome. And this is sort of an extrapolation on that, and a more unique or efficient way to do a similar thing. And per pickup, you can imagine with a Merkle tree of several depths, a single pickup might cost 3 or 4 transactions, but in the end, everyone gets to disperse their tokens, and it's all relatively efficient. We've proved this out in our benchmarks, which are available in our docs, so you can check that out there. So going on to our next thing, so pre-signed transaction chains. Once again, we also allow for an interesting pattern where pre-signed transaction chains can be used to do things like digital subscriptions. And so effectively you can assign, say, 12 months of worth of transactions ahead of time using a single output. And then only under certain pretenses or under certain circumstances, those transactions can be triggered on chain and then dispersed to whoever you're subscribing to. So this use case was referred to in the Reddit challenge, and it was also something we were able to achieve quite easily with pre-signed transactions. And so this is just another use case for having this kind of tech inside of our rollup. As well, one other interesting aspect to having an 8 input in, 8 output transaction format is that with if you want to approach something like a privacy mixer, you can do all sorts of interesting mixing patterns. And we already have a project that's researching and experimenting on this, largely because as well, Bitcoin is just so damn limited that in order to experiment with the UTXO model, we're sort of the next best thing for them. And so, you can imagine scenarios where you want some level of privacy. And obviously, you're not going to guarantee full privacy. You're not going to guarantee, something like a bulletproof kind of level privacy. But what you will guarantee is that, you're making it much more difficult for, say, your friends or local businesses or other things around you to be able to see, into your transaction history easily. And I think this is, one great aspect of having this as your base transaction layer is that you can kind of get this sort of activity done. So in terms of our timeline, and how much time do I have left? Do I have 15 minutes left?
Yes, you do.
Okay, just check in on that. So in terms of our timeline right now for Fuel and our optimistic rollup releases, right now we're targeting mid Q4 for version 1 mainnet launch, and that includes all of the pre-signed transaction tech, some really nice deposit and withdrawal tech as well, lots of all the different features you saw today, and basically we'll give it'll open up the field a little bit for our type of execution model, and sort of add more to the rollup space. So that's our current mainnet launch, and it sits around 500 TPS in terms of throughput, which is still pretty good considering you're not using any new key formats. So it's just vanilla Ethereum keys, and it really it should allow people to get a taste of what Fuel is about and why we're taking the approach we're taking. So that's our current mainnet launch timeline is around mid Q4. So it's coming up. Our next major drop will be at the end of Q4. So this will feature our version 1.5 testnet. So this is where we'll be able to really turn up the heat and kind of achieve our highest throughput that we can think of right now, which is 4,300 TPS. And so you'll see sort of our compressed transaction formats, the use of BLS. And once again, thanks to the Hubble team and Barry for all the work they've been doing on BLS. It's been fantastic. And I think we're looking to make sure we have some kind of standards around that key format so that every optimistic rollup can benefit from the same kind of key format, and we can kind of get rid of those signatures. So that's going to be our end of Q4. And then Q1 2021, we'll have our specification lined up for our virtual machine, which I'll talk about in a second. And then lastly, a testnet for our version 2.0 release. So that'll feature, hopefully, if we can hit all our targets, a new virtual machine specification for Fuel, which will provide some nice abstractions over all the things we want to get done in the optimistic rollup context. As well, it'll also feature, how we get it done in parallel with mass throughput and in a sustainable way. So hopefully we'll get to that testnet release so long as we hit all our targets and don't have any huge major setbacks. So just a small word on our version 2. So currently our version 2.0 is focused on UTXO-based Ethereum style smart contracts. So we're still finalizing our specification for a virtual machine here. But effectively, it'll provide one of, if not the most performant options for doing parallel transaction verification, and particularly without global state. So we've constantly made an effort to avoid global state and global state serialization. And so this really gives us, a lot of opportunities for really efficient, really performant design patterns. And you can look at John's work on strict access lists and UTXO smart contracts. There's the link below there if you want to read more about what we're doing there. We really think, given that the space has a lot of, or will have a lot of EVM oriented and account oriented options for people to, attempt to scale their work and their efforts, still using Ethereum as a base officiation layer, that UTXO based transactions will provide a huge throughput benefit, and hopefully we'll be able to really demonstrate that with a full virtual machine, basically without losing pretty much most of everything that everyone loves about the EVM and about Ethereum, but with also providing all the benefits of parallelism, with minor trade-offs. So just to talk about where to find us. So our Twitter is Fuel Labs _, website fuel.sh, GitHub, and a Discord link there. So yeah, we purposefully left, I think, quite a bit of time for some questions and to go back and forth. I think we're pretty curious to see if what people want to ask in terms of questions and how we're doing things. Yeah, we can probably start that.
Thanks, Nick.
Awesome.
I think from our side, given the slight delay in the stream being looked at our audience,
right,
we have a delay coming in with a question. So I'll urge all of our audience to send questions as we are kind of talking. In the meantime, I think what will be super helpful for us is that we'll do is I'll get us started on just kind of comparing Fuel to the other rollup approaches. Kind of how do you think about what the trade-offs are and sort of what's good or bad about the trade-offs for each of the other solutions out there? And maybe we can just do that until we get more questions in.
Yep, for sure. So, from the beginning, we decided to go the route of the optimistic rollups. Our expertise is more around fraud proofs and optimistic rollup design. And that's thanks to John's efforts on the team. And so that's the first thing is, we're an optimistic rollup, not a ZK rollup. And I'd say the main thing we think about there is that we like the properties of the fraud proofs and the 1 week delays, and we like those trade-offs over ZK related trade-offs. And we think we can really achieve, high throughput and block production, without really losing much for security and for user experience. And so, and thanks to the efforts of Barry and, the foundation, we get to, benefit from aggregate signatures, and aggregate signatures allow us to get rid of that troublesome signature data, which really is where you're going to get the maximum amount of savings. So for us, yeah, I think we're, our main focus versus the ZK rollups is that we focus on aggregate signatures and we don't mind the trade-offs of fraud proofs. We do think they're as or more secure in that sense. And once again, you can do block creation validation on easy consumer hardware. So it's really, really accessible and democratized. And then in comparison, just to quickly touch on it from the other optimistic rollups, I'd say our main focus is that, the other rollups right now are focused on servicing what Ethereum currently is. And I think that's awesome. And we need that kind of work. But for us, we're taking sort of a different approach where we think we can add a lot of benefit by showing people sort of another generation of what's possible and potentially trying to approach the problem from bottom up. So approaching it from parallelism up versus, code and compiler down to what's possible. So that's more or less, I think, the differentiating factor for us. It's kind of, it's a different kind of work and it's a different kind of approach. But once again, we're really happy with the way the ecosystem is developing, and we're super excited for all the launches coming up. I think the space is really developing and we'll have lots of options.
Awesome. So we have a couple more questions that have come in, so I'll kind of just start asking them until we're at time.
Go for
the
it.
Next question is, what other features besides TPS are most important when designing a rollup service, and sort of what other things should we be excited about?
So I think when designing these rollups, I think you want to really focus on your use case and what we need from the user perspective down. So, if the user needs cheap transactions and they need it to be non-custodial, and they whatever the user needs, we should aim to provide them with. And I think we have a lot in the ecosystem, especially if you think about stablecoin access that we have. To me, stablecoins and lending protocols are still the hugest value add we have in the space. And I love all the fruit coins and everything. It's great. But if we can really scale and provide a lot of throughput and exchangeability in various formats for users, particularly of those stablecoins, I think that's like one of the greatest benefits we can add to the world. So for me, I would just say with rollups, you should design them around specific use cases and try to target them specifically to what users need. And it's that simple. And if we're making that process better, then we're doing our jobs. Yeah.
No, it's great. I think this kind of sparks another question and really fits nicely into it is, if you're imagining a world where there are use case specific rollup services, how do you kind of think about solutions that help you do cross layer 2 transfers and kind of anywhere from frameworks to best practices, or how should one think about that, and kind of how do you imagine that world panning out?
Yeah. So I think that's going to be one of, if not the most important questions over the next year or two, is what the hell is going to happen with liquidity and where is it going to go? And what is it going to do? So I think we should look at Ethereum layer 1 as still base settlement layer for issuing assets and for creating your protocols. I still think it gives you the maximum amount of options. But in terms of having liquidity on different systems, I think we should be open to, once again, really available hash time lock contract swap systems between these different systems so that we're not too locked into anything. This goes for being locked into not only different rollups, but being locked into different versions. So we will need easy ways to transit between different layer 2s and layer 1s. And so, HTLCs provide basically all we need. And I think even state channels might even give us even another level of speed there if we can do it right. So I think hash time lock contracts are they're a way to free us from these liquidity questions, and we can just get on with experimenting with where development's going to go across the different layer 2s and layer 1s, because right now it's so early that if we lock up a lot of liquidity on anything, it'll either want to get off or it'll have to get off eventually. So I think we'll just touch and go, and we'll see what things like hash time lock contracts can bring to the table. Yeah.
Got it. And we have another one, and if you don't have enough context, I'll ask Samuel to expand, but if you do, I think it'll be great for the audience to get some context too. And the question is, what do you make of the capital efficiency argument that was put forth by Starkware? And kind of what do you think about that? And for the audience, like if you can also just tell us what that argument is by Starkware before answering that, that'll be great as well.
Yeah, I have to say I just briefly skimmed that, so I don't I don't know if I have a huge depth yet. I just saw that today. I'm currently off Twitter, so
no worries.
I'm getting off the hype.
You don't have to directly answer that. Sam will follow up with a different question there, and the question is, how does delayed finality affect composability, and how long would it take for Fuel or any other layer to kind of help solve this?
Right. So not to drag again, and I seem to keep talking about HTLCs, unfortunately. But yeah, with the optimistic rollups, the trade-off is that you can do smart contracts, you can aggregate the signatures, and you can get all the throughput you want. You can do it whatever way you want, and you can do that on consumer hardware generally, and without needing ZK proofs in any way. So you get a lot of benefits. The trade-off is that there's a week time delay to remove your assets if you don't have regular access to HTLC liquidity. But the thing is, to exit these chains, you just need any party on Ethereum or any party on any other layer 1 to be sitting with some liquidity and running a liquidity provider, which they'll make fees for, and that will be able to basically solve that issue. In my opinion, I think it sort of optimistically solves it, but it's a fantastic solve, and it sort of gets the job done from what we can see, and we'll just have to see how it plays out. Yeah.
Awesome. Well, Nick, thank you so much for your amazing talk and answering all of our questions. If you, I'm sure there's a lot more questions